All right, so let's go over question number 5 under the estimating a limit numerically. So notice here that in this problem, they give you a table of values. So if we look at the question for number 5, they're wanting us to find the limit as x approaches 4 of x minus 4 all over x squared minus 5x plus 4. So this right here is the function that we're working with. And just a couple of things here. Notice that these x values right here to the left of 4 are getting really, really, really close to 4 from the left-hand side. Same idea on the other side. Maybe start from 4.1 and you get really, really, really close to 4 from the right-hand side. So you have x values approaching from the left-hand side towards 4, and you have x values approaching from the right-hand side towards 4. So in order to help us answer this question, you're going to want to use your TI-84 calculator. What I always recommend to do beforehand is always clear the calculator. So I always like to select second plus 712. Clear. So now that our TI-84 is cleared, there are just two things you have to do in order to help us answer this question. You're going to want to go to mode. One little thing I want to point out here is please make sure that your calculator is set to radian mode. It should already be defaulted at that mode. So make sure that it's in radian mode. But one important thing I want to bring to your attention here is to go to the float option. So I'm going to go down and I'm going to want you to select the number 3 right there. So I'm going to go to the right and go to 3, hit enter, and I'll go back. So yep, 3 is already selected, so we're good. Now we're going to go back to our home screen. So second, quit. Now there's one more thing I'm going to require you to do here. This is also very important. You're going to want to go to second window. So second window should take you to this screen right here called table setup. Under table setup, you're going to want to go to where it says independent. And I'm going to want you to select ask here. So you're going to go down to independent, go to the right, and select ask. This will actually allow us to enter any x value that we want under our table option. So instead of them giving us a whole bunch of x values, this right here will allow us to enter in our own x values. So just make sure that the ask option is selected. So then now we know that it's selected. We're going to go back to the home screen. So second, quit. Now our goal here is to enter in the function that they gave us in this problem into our TI-84 calculator. So in order to do that, we're going to go to y equals. And here I want to emphasize this point a lot. Please make sure that you enter in the parentheses because sometimes a calculator won't be able to read the function as you're looking at this. Sometimes it can get confused and it'll cause some issues along the way. So just please make sure that you enter in this in parentheses and then the bottom in parentheses as well. So let's go ahead and do that. So once again, we go to y equals. We're going to enter in that function. It should be x minus 4. Make sure that you have the parentheses, x minus 4. Close the parentheses for that term. All of that is going to be divided by parentheses x squared minus 5x plus 4. And please do not forget to close the parentheses for this whole expression right here. So now that we entered in our function, if you want, you can click graph just to get an idea of how it looks. So the TI-84 graphs it for you. You have some type of vertical asymptote here. But what I want you to do at this point is go to second graph. Second graph. That'll bring you to this table. And notice here that there aren't any x values being listed. So that's good. This is exactly what you want to see. So that setting that we changed in the beginning will allow us to enter in any x value that we want. So going back to our problem here, what I would recommend is you enter these individually. I wouldn't recommend plugging in the 4. I would just recommend entering these values that are blank, okay? So these values will allow us to figure out and estimate what the limit is at x equals 4. So then for the first step, we're going to enter in x equals 3.9. So let's go back to our calculator. We're going to type in 3.9. We're going to click enter. And there you go. That spit out a y value. That is going to be our first y value in our table. So 0.345 is going to be right here. 0.345. Okay. So now let's go on to the next one. 3.99. 3.99. That gave us a y value of 0.334. 334. And then now let's enter in x equals 3.999. And that gave us a y value of 0.333. Let's go back to our table. 0.333. Okay, so we're done with those x values. Now let's go on to the right hand side and let's start off with 4.1. So x equals 4.1. 0.323. We're almost done here. All right, so our next x value is 4.01. You get 0.332. And then lastly, we're going to enter in this x value, 4.001. 4.001. And you get 0.333. Okay. So, when we're using 3 decimal places, these are our y values that we get. And in order to answer this question now, here's what you want to ask yourself. As we go from the left-hand side, starting at x equals 3.9, when we come from the left-hand side and approach x equals 4, what y value are we approaching? Keep in mind that 3.999 is really, really, really close to x equals 4. So as we're going from the left-hand side, from x equals 3.9 to 3.99, sorry, from 3.9 to 3.99 to 3.999, what y value are we approaching? Same thing on the right hand side, starting from 4.1, going towards 4. From the right hand side, what y value are we approaching? Ultimately, what you'll notice is that from the right hand side and the left hand side, when you get super close to x equals 4, it'll actually get really close to 0.333333. So the answer here would actually be, and this is, remember, this is just estimating, but if we get super close to 4 from the left or the right, you'll get 0.3333, and it keeps on going. And another way to represent this decimal is just 1/3. So just based on this table, we can estimate that the limit as x approaches 4 of this function should be 1/3. And this should be the answer to this question.